Hello and welcome to the first video in this workshop. To quickly recap, what we are going to do is take this model and rig it. If you would like to see how this was made, you can find details on the screen now showing where you can find the workshop. Looking at the model, we can see that we will primarily need a biped rig, but his legs are more like canine limbs, so we will need to tackle those in a different way. That just means the workshop covers more areas because we will see how to create both biped and quadruped limbs. Now before you start any rigging work, it's important that you examine the model thoroughly. That is, unless you are the person who built it. But even then, there are some areas that you should be aware of. Most of the time you will be given a model from a work colleague or a client and asked to build the rig, but don't assume that because someone else has built the model that it's ready for animation. At this early stage, it's crucial you check the following areas, because doing so now will save a lot of time and headaches later in the rigging process. Okay, so let's bring back the UI, and to quickly show and hide, all you need to do is press Ctrl and space. Let's switch to the side view. I'll just hide those lights. The first thing we need to check is the actual scale of the model. You should always check with the client so you can get an exact size. Our rig will be scalable, but it's better for the animators to be working with a clean rig from the offset rather than one whose size has been changed. First, we go to Windows, Settings Preferences, Preferences. We need to check what units Maya is using. Let's look under the Settings tab. Here we can see the working units. By default, it's usually set to centimeters, which is exactly what we need. Now we know the working units, we can adjust the grid so we can see how tall this creature is. Let's close that. And now go to Display, Grid and open the options. Let's reset this and apply it. You can see that the grid has changed, and each square now represents 1 centimetre. Now, the last thing we need is to have to count each one of these to work out the right size, but luckily we can adjust the grid settings to simplify things. We ideally need a line at each metre, which is 100 centimetres. So let's change each of the units to 100, so we just get a line at every 100 centimetre point. We should also reduce the subdivisions to 1 because we just want to see the main lines. If we apply that now, the grid has simplified, and we can instantly see that the creature is just over a metre tall. According to the client, ideally he needs to be closer to 1.8 or 1.9 metres. We can now adjust the scale to make him bigger. The next thing we need to check is that his feet are actually on the floor plane, and not floating above it or below it. I have a floor plane in the scene already, which is just a polygon plane which I added, just so we can see the shadows and also so we know where the real world ground level is. So we can see he is clearly below ground level. I'll just turn off the textures. So there we can see he needs to be moved up. That looks better. Bring the textures back. Okay, so that's the scale and vertical position fixed. He is roughly 1.8 metres tall now, and his feet are planted on the ground. Perfect. Now we need to make sure the horizontal position is right. Let's switch to the front view. So this is the grid line and it represents the middle of the scene. What we can see is that the model is offset slightly. We need the middle of the model to be on this grid line. This makes using Maya's symmetry tools easier and is better when creating joints and also mirroring skin weights. Again, moving this back will make your life easier. So let's select the main group. And this time I'm going to use the snapping tools to help me snap to the grid. All I need to do is hold down X, and you will be able to see the grid snapping icon update up here to tell us it's active. If I just move along the X-axis now, you will see that the model snaps to the grid points. I'll just double check that the middle of the model is sat exactly on the grid. Obviously this works better if the model is symmetrical, just like this one is. Okay, that's the positioning updated. Whenever you do anything like this, it's good practice to also freeze the transforms, so the models don't have any translation, rotation or scale values left on them. Always maintain clean values. To do this, we select the main group and go to Modify, Freeze Transforms and open the options. I'll reset the settings first and click Apply. Because we did this on the main group, it will also apply it to everything beneath that group. One other step you should take is to update the pivot points on each model too. You can do this quickly using the Modify Center Pivot tool. This isn't essential, but it's just another step that I like to do with my models before I rig them. Okay, those are all clean and centered. Next, we need to check the eyes. Some character modelers like to pose the eyes sometimes, but that's not ideal for the rig. I'll just isolate these. So we can see here that the eyes are rotated. They are rotated in each other view too. Ideally, we need them to be looking straight ahead. This is because we will be adding eye controls in front of the head, so the eyes need to be looking at the controls and not below them. The alternative is to build the controls with an offset on them, which can cause problems with the rig and animation, especially if you are planning on transferring animation between characters. So it's better to have every character looking dead ahead, and then the animators can pose the eyes later if needed. You also need the eyes to be focused on the controls themselves, so what we need to do is move these back. Just rotating them will be fine. Actually, I can update one eye and then copy the values across. So let's just press H to hide this one. We want the wireframe to be back at the default position, so as close to matching the horizontal and vertical lines as possible. Yeah, that looks better. Once done, you would just freeze the transforms again to clean up the rotations, but we need those values for a few more minutes. Let's bring back the other eye. I can just press Shift and H to make the last hidden objects visible again. So all we need to do is copy the rotation values across. The right eye still looks wrong, but that's because we need to invert some of the values because this eye is mirrored. So we can just remove the minus from the Z rotation and add it to the Y rotation. Okay, that's much better. Now we just need to freeze the transforms on the eyes. And make sure the pivots are centered too. Again, this isn't essential, but it can come in useful sometimes when you need to find the exact center of an object for joint placement. So that's the model's scale and position corrected. Now we need to check what is probably the most important element of any model, and that's its topology. I'll switch on default lighting and disable the textures. I'll also turn on Wireframe on shaded so we can see how the polygons are formed. So now we can see the model. The first areas I like to check are the head and face. When working on a facial rig, you need to make sure the head can support one, and I can see straight away this one won't. The mouth has been modelled closed, so we can't open it. If I hide the head, there are no inner mouth, teeth or tongue models. These elements, along with the wall of the mouth, are often referred to as a mouth bag. So if this was to have a facial rig, I would need to contact the artist who built it and ask them to update the head. Other areas we would need to check are how the edges flow along the surface and how many edge loops are around deforming areas like the eyelids and lips. There needs to be enough topology so the eyes can close and the lips can deform. In this instance, these areas would need adjusting too. There's not really much point in doing it at this stage because we're not going to be adding a facial rig. When building a head model, or in fact when building any organic model, you should try to follow the natural muscle lines. So basically, the polygon edges try to match how the underlying muscles are formed. This means the model will deform in a much more natural way when animated. So for this workshop, it unfortunately means we won't be building a facial rig, but we will be looking at a more detailed facial rig setup in a future course. Let's instead focus on the rest of the model. It looks like there are quite a few problem areas here. We have a lot of triangles, which are not an issue when placed correctly, but these seem to be all over the place. Here, for example, in the inner thigh. We have similar issues up here with lots of triangles which aren't needed. There are triangles up here, and down here, and here. In fact, there are a lot of areas that need reworking on this model. The problem with all these triangles is they will cause problems as the model deforms. The surface will pinch and tear in areas, and in some cases cause unwanted creases. The fingers need to be able to bend, so it looks like we may need to add another edge loop around the knuckles. We need this because as the finger bends, the polygons around this area will stretch and ultimately look very sharp and angular. Having another edge loop will give us a nice natural curve instead. Lots more triangles up here. Okay, so to be honest, at this stage I would normally send this model back to the artist with a list of suggested changes and improvements. But instead, let's use it as a learning exercise and update the model ourselves. It is important to state though that you shouldn't do this without the client's permission. They may have a pipeline which needs to be adhered to, so they may have to do the updates themselves in-house. Okay, so let's update this topology. First, it's good practice to back up the main model. So let's duplicate it and rename the original. And then press H to hide it. We need a copy because later we will use that to update this model's UVs. Let's isolate the main body model. Ideally, we need nice clean lines made up of polygon strips with quads, not triangles. Something like this model. Okay, let's look at this area first on the inner thigh. Because this model is symmetrical, we can use the symmetry tools to work on one side and it will automatically update the opposite side. Holding Ctrl and Shift, right-click to bring up the marking menu. Now go up to Symmetry and then make sure Symmetry is enabled. You can now see the edges are highlighted blue, meaning that they are symmetrical. If they turn red, it means that those edges aren't symmetrical, so any changes you do on this side will not be updated on the opposite side. Now this is basing the symmetry off the world position of each edge, and as you can see, it's mirroring across the x-axis. If you have issues with the model, you can also base it on the model's topology too. You just need to define an edge which will be the mirror point and choose topology instead. Okay, let's switch back to world. You can also mirror across the other axes too if needed. What I want to do here is simply turn these two triangles into quads, so they join the other quads below. The quickest way to do this, which will be less disruptive to the actual model and its UVs, is to select these three edges here, hold down Shift and right click to bring up the marking menu, and go down to Connect Components. I'm going to use the Insert with Edge Flow option 2 because that will add the edges while also maintaining the natural curve on the model's surface. Let's apply that. So that's given us more quads. But what we can now do is select these edges, bring up the marking menu again, and go to Merge Collapse Edges. Collapse Edge. You can see that this has now left us with 4 triangles, but we can quickly turn these into quads. Just select and delete the inner edges. Now let's do the same down here to connect these triangles. So select the edges next to the triangles, and connect the components to add an edge loop. Now merge the upper and lower edges to convert those quads into triangles. Finally, delete these edges to turn these into quads. So that's the inner thighs looking much better now, and the other side has been updated too. The new edges we added are making the surface look wrong now because the surface normals in these areas are set to hard, which makes it look like there's a crease. So we just need to soften these back down. Right click on the model and go to Object Mode, so we are working on the model as a whole and not the components. Although you could just select these edges and do the same thing. Now hold Shift and the right mouse button to bring up the marking menu again, and go to Soften, Harden Edges. Soften Edge. That's fixed the surface now. If we look over in the channel box, we can see that all the work we have done is building up under the input section. This is the modelling history, and it's good practice to clear this when you're at a stage that you're happy with the model. To do this, go to Edit, Delete by Type, History. And that's all baked into the model. So we've cleaned up the topology in this area, but the edges aren't flowing in a nice uniform way. So let's look at fixing that next. This time we're going to use Maze sculpting tools to help even out the spacing. Go to the sculpting shelf and click on the Relax tool. As you can see in the tooltip, this will smooth the model's surface without altering its shape. This will give us a circular brush to work with. Let's make sure symmetry is on, so right click on the model and go to Symmetry. Also make sure you select Object X, so it will mirror across the X-axis. Now as we paint, the surface is evened out, giving us much cleaner topology. That was quick, right? It's not without its downsides though. The problem is the vertices have moved, but so have the UVs, so the texture will now look wrong. Let's bring back the textures and take a look. Now because of the simple pattern in this area, it isn't immediately noticeable, but we need to keep to the original UV layout because changing it will affect the other texture maps, like the normal map for example. Let's quickly bring back the original model and compare. Okay, so we can see some stretching here, compared to here. We can quickly fix that though using the original model, so it's a good thing we copied it. Select the original model and then add the edited one to the selection. Now go to Mesh, Transfer Attributes and open the options. This tool will copy elements of one model to another so we can use it to copy the UV layout. The main setting we need is this one, UV Sets. Set to all or current depending on the model, but all is a safer bet. Let's just use World as the sample space because these models are in the same place, and click Apply. You may need to rewind to see it, but those star patterns moved back to the original position, so the UVs are now fixed. Okay, let's turn off the texture and continue working. I'm just going to speed this section up slightly because we're just repeating the process and I don't want the video to drag on and on. All I'm going to do is repeat the same process. Add edge loops to help remove the triangles. Soften the surface normal. And then we're just going to use a relax tool again to even out the vertices. And then finally use the transfer attributes tool to update the UVs. If you do want to see a more detailed video on topology or one on model preparation, you can find both on my YouTube channel. Okay, so now we have an updated model. I've spent some more time updating the topology, so you can see it's a lot cleaner and will deform in a much more predictable way. As mentioned earlier, it's always best to try and make the edges of your model follow natural muscle lines, but it's also useful to follow crease areas too when working on clothing, like you can see here around the hips. The topology is much better here too. I also added an extra edge loop to the knees to allow for the deformation. And into the knuckles too. Now there are plenty of other areas that need cleaning up, but I didn't really have time, so I just focused on the main areas for now. I may update the model later on as we work on the different areas of the rig, but we'll see how we go. So that's the general body topology, and yes, this is a game model, so it should be optimized, but you should never sacrifice how the model deforms so you can squeeze out a few more polygons. Speaking of optimization, another area that needs looking at is this buckle. There's far too many polygons here, especially for something that isn't seen close up. I'm getting distracted though. This won't affect how we come to rig it, but it's another thing to keep in mind if you're building a model. A good way to judge how many polygons you need to use in a model is to see how close that area is going to be on screen. If it's never going to be really close to the camera, then you don't need lots and lots of polygons. So in comparison, this area works well because you do need those details around the outside of the circle. So those extra polygons are needed here. Okay, there's another area of the model that needs adjusting, and that's the pose. The arms here are too relaxed, so need raising into more of an A pose. Ideally, when posing your model, you need it to be in a relaxed pose, but you also need the arms raised slightly so that you can paint the weights under the arms. So the quickest way for us to adjust this pose is to use joints and then raise the arms. And I will be demonstrating joints and how they influence a model later in the workshop, so I won't spend any time showing you how to set this up just now. I also prefer the palms to be facing down, so I will probably update that before the next video. Again, just using joints to deform the model for me. This is more of a personal preference though, but ideally having the palms facing down again means to get into a natural pose means all you need to do is just lower the arms. Okay, one final tip before we move on. When working with a model like this, which is symmetrical, it's best to have elements which are also symmetrical on either side combined into a single model. This means when it comes to painting weights, you can focus on one side and then simply mirror the weights across. This can save you a lot of time, especially if you're working on hands for example, or even fingers. They're the worst. You can just spend time refining the fingers on one side and then mirror the weights across to the other. Luckily, the main model is already a single mesh, so we will be able to mirror the weights easily enough. We can see with this hip clothing, there is one on the other side, so it makes sense to combine them into a single model. Just select them and then holding Shift and right click to bring up the marking menu. Now go to Combine. That's now a single mesh. We can do the same with these hooks. We can also do it with the hinges too. The sashes are also symmetrical, so let's combine those. I'm sure there will be other areas to combine, so I will investigate those before the next video. Okay, so that's just a quick look at what you should be checking on when you're sent models to rig, and don't be afraid to ask for changes. At the end of the day, if there are problems with the model that are going to impact on how it deforms, it needs to be checked before any rigging starts. So now we have the model in a much better place to start rigging. So in the next video, let's take a look at Meyer's joints before we start to build the base skeleton.